Here's our last example from this section. We want to graph y equals the ln of 4 minus x squared. If you remember, the ln of x has a graph like this, and I draw that to remind you that the argument of the ln needs to be a positive number. That is, the domain of ln of x is positive numbers. So we need 4 minus x squared to be greater than, strictly greater than 0. And if you want, you can factor this 2 minus x, 2 plus x needs to be greater than 0. Or if you want to think about this graph would be a parabola opening down with intercepts at -2 and +2. So this graph opening down would be above the x-axis. The y's would be positive from -2 to +2. So the domain of this function is between -2 and +2. There's our domain. Okay, also we can notice that the ln of x has an asymptote at its endpoint, so we should suspect that the ln of 4 minus x squared also has some asymptotes. To check it out, we can take the limit as x approaches -2 from the right of the ln of 4 minus x squared. Okay, so -2 from the right is a little bit bigger than -2, like -1.9999. When you square that, you get a little bit smaller than 4. 4 minus a little bit smaller than 4 is a little bit bigger than 0, and the ln of a little bit bigger than 0 is, as we saw in our sketch just a second ago, -infinity. So that is a vertical asymptote when x equals -2. We can do the same type of thing with +2. However, if we check symmetry and do this, we see that we have the ln of 4 minus x squared again. Since f of -x is the same as f of x, that means we have an even function, which means there's y-axis symmetry, which tells us that we're going to have a vertical asymptote at x equals +2 as well. We don't have to worry about end behavior since the function is only defined between -2 and +2. So our next thing to check would be first derivative information. So the derivative is going to be a log derivative rule. So derivative of ln of stuff is 1 over that stuff times the inside derivative from the chain rule. So 1 over 4 minus x squared times -2x. So that's -2x divided by 4 minus x, sorry, 2 minus x, 2 plus x, factoring with the difference of squares. And at this point, we can find our critical values. There's a critical value when the numerator is 0, that is when x equals 0. And then setting the denominator to 0, we have x equals plus or minus 2. And we'll recall that plus and minus 2 are not actually critical values. since they're not actually in the domain, but they are important for our number line and for our graph. And I'm going to put some dotted lines here to remind us that there are vertical asymptotes there, and I'm going to X this stuff out since this is out of the domain of the function. So, taking a test value, such as -1, -2 times -1 is a positive number up top, and then 2 minus -1 is positive, and 2 minus 1 is also positive. So we have an increasing function. Then we could guess, using symmetry and the fact that it has a y-axis symmetry, if it's increasing between -2 and 0, it should be decreasing from 0 to 2. We'll test that out. -2 times 1 is negative. On the top, 2 minus 1 is positive. 2 plus 1 is positive, and it is in fact negative. So decreasing, which means we have a local max. It is also an absolute max. It has to be an absolute max, since the function's only increasing then decreasing. Our next job is to find the second derivative. So the second derivative, I'm going to use the first line here to find the second derivative. Since then I don't have to, I can avoid the product rule in the denominator. I'd rather do a power rule. So derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. Alright, looks like we can factor a 2, and I think I'd like to factor a negative as well, and note that a negative and a negative will give me a positive over there. So factoring out -2 leaves me with 4 minus x squared plus 2x squared over 4 minus x squared squared. It would be horrendously wrong to try to cancel this, right? Combining like terms gives us -2 times 4 plus x squared up top and 4 minus x squared squared on the bottom. Taking a look at this equation here for the second derivative, we'll notice between -2 and 2 for x, 4 plus x squared is a positive number. 4 minus x squared squared is also a positive number, and -2 is a negative number. So what that means is we have a negative times a positive times divided by a positive. So the second derivative is negative. If you want to draw a number line for this, what we have is -2, +2 from the denominator, and then negative. Remember, this is outside of the domain, outside of the domain. So our function is always concave down. All right, now we'll see if we can put all that information together. Looks like we have all of that. When x is -2, we have a vertical asymptote. When x is 2, we have a vertical asymptote. We have a maximum when x is 0. When x is 0, the y value will be the ln of 4 minus 0 squared, or the ln of 4. ln of 4 is, I don't know, a positive number. There's our maximum. We have some intercepts here and here, and if we want, we can find those intercepts by solving 0 is equal to the ln of 4 minus x squared using from logarithmic to exponential form. We would have 1 is equal to 4 minus x squared, and rearranging x squared is equal to 3, so these values are plus or minus the square root of 3. And as we know, plus or minus square root of 3 are a little bit closer to 0 than plus or minus the square root of 4, which would be 2. So those zeros make sense with our picture. And we have everything to make our graph.